And, you know, whether you're talking about an experiment, you're talking about a maze, a rat traveling in a maze, excuse me, or you're polling people at a voting precinct, or you're polling people in the parking lot who drives a truck or an SUV or a car, okay? Whatever the case, if you're going to present it and you're going to show off, or not show off, you're going to show your intelligence of probability and statistics, you don't just survey 5 people. You survey 50 or 500 people. You don't survey 5 and say, okay, because that's what's called, in the real world, that's called half-assing it. Okay? Law of large numbers is the opposite of half-assing. Law of large numbers basically says I put a lot of time into this, and the numbers that come out are valid. Throw out all the outliers. You throw out the errors, and what's left should be good data. Because that's the first thing people are going to look at. When you present your data, they're always going to look at the number, which is N. Write that down, N, y'all know that. N is the total, lowercase n. They're going to look at the bottom of the poll, or they're going to look at the bottom of the graph, or they're going to look at the bottom of your research and see, what is N? Is N 100 or is N 10,000? The larger the number, the better. And that's what all of this slide presentation is basically going to say. Okay, this is the law of large numbers with a die. Okay, I'm not going to get into it, but as you can see, once you hit a certain point, you know, there is 0.167. What does that blue line represent? That blue line represents the what? The theoretical probability. The probability calculated by mathematics. The 1/6. And then what happens? Well, after about 550 rolls or 525 rolls, what happens? The probability is above the mathematical probability. And then what happens as the rolls go further? What happens? It starts converging onto what? Remember me telling you about the roll of quarters? Did I tell you about the roll of quarters? Okay, Miss Riddle, she don't remember. What about y'all?
I think you mentioned something about it, but...
2 students and a roll of quarters at MIT?
Yes.
Okay, and they basically found out that it took 100,000 rolls for that. So here it takes basically around 4,500 rolls or 4,000 rolls for that 0.167 probability, physical probability, to actually match the what? The theoretical probability. It took 100,000 simulated flips of that quarter for the physical probability to actually get to the what?
Can you try to loop Oconee in?
Well, I tried twice.
I think they were going to the restroom when you were trying.
Well, also, Oconee is not starting their stuff up. That student has to come in and start it up every morning.
Okay.
I don't know who's in charge of it up there.
I'll let Tim know that. He'll make sure it gets done.
Okay.
All right.
Thank you. It's my fault. I tried to bring them in twice, didn't I? Yeah, there's the slacker.
Oh my God, I've been here since 8:40.
I tried to call you in twice, bud.
Oh, I had an idea that you did. I just had to go to the bathroom. I wasn't.
Okay, that's all right.
Yeah.
All right, we already started. We just on the second slide. First slide wasn't really anything. And plus, we've already talked about the law of large numbers. And this is a graph showing you exactly what I showed you with the quarters. And it took 100,000 rolls or 100,000 flips for that quarter to reach 0.4999995. Well, this thing says about 4,000. You're starting to see the physical probability of rolling a die actually come in to the blue line, which is the theoretical probability. So, and that's what the law of large numbers says. Okay? A roulette wheel, I think, have we gone over the roulette wheel?
Yes.
Okay? Roulette wheel has 38 numbers, 18 black and 18 red. That's 36, plus the number 0 and 00 in green. Assume that all possible outcomes, what is the probability? Well, we've already done this. I didn't even know this was on the slides. Okay? There is the probability, 18 over 38. So that's the probability of success. What is the probability of failure? Well, what's the complement of 18 to 38? 20 people.
20?
Okay? So the probability of A with a line over the top of it, that's the complement, is 20 over 38. And that's probably what they're going to say next. Okay, they didn't. If patrons in a casino spin the wheel 100,000 times, about how many times will a red number be the outcome? The law of numbers tells us that the game is played more and more times in proportion. Well, there's no way for y'all to actually calculate it. So, well, they take the 0.474 and multiply it by 100,000. It would take at least 47,000 spins for it to actually get that probability. I'm not going to ask you that on a test, okay? Okay, so you take the 47, let's take the back track. The 474 probability, you take that probability and multiply it by 100,000 times. All right, how many zeros are in 100,000? 5 zeros. So you move this 5 places what? To the right. Okay, and that's where they come up with the 47,400 times. 5 places to the right. You got to change it into 0.474 first, and then you move it over 5 times. I'm not going to ask you that second part. I'll ask you the first part, though, and then I'll ask you what the complement is, and then I'll ask you to find the odds against, and then place a bet. We went over that. Consider 2 of each with its own value and probability. Okay, I do not cover the expected value, but we will talk about it, but I'm not going to ask it on the test. The formula can be extended to any, okay, write this down. Event 1 times event 1 probability plus event 2 times event 2 probability. So you might want to write that down because they're going to ask you the expected value in your homework, and that's the formula you use. That's probably where you got confused.
Probably, like she skimmed over the entire class, basically.
Okay.
Like she did not slow down at all.
Maybe that's what I need to do. Maybe I need to speed up for y'all.
No, because that's how I failed.
I'm gonna be honest with you. If you fail Math 120, that is usually a problem either with the student or with the teacher, or both.
I studied all day, every day, as much as I could, with work and my other 5 classes. It was insane.
Well, you should have put that on the evaluation.
I'll read
Okay. And also you need to put on Rate My Professor, whoever the professor was. Okay. So event 1 value, and they're going to give you an example here in just a second. Suppose an automobile insurance company sells an insurance policy with an annual, what does annual mean? Yearly payment. So write yearly payment of $200. Based on data from past claim, the company has calculated the following probabilities. An average of 1 in 50 will claim $2,000. An average of 1 in 20 will file a claim of $1,000. An average of 1 in 10 will file $500. What they're giving you is they're giving you the probabilities and they're giving you the amounts. Okay, assuming the policyholder could file any of the claims above, what is the expected value, use that little formula, to the company for each policy. And there it is. Okay? The 200 is what you multiply by. Okay? Will be positive income with a probability of 1, since there will be no policy without the receipt, blah, blah, blah. The insurance claim will be negative expenses. Okay, anytime this is insurance, the insurance has to pay out something. If the insurance has to pay out something, then that's a negative for the insurance company. Okay? So, there we go. 200, this is what the insurance company brings in. Why does it bring it in? Because you're paying it to the insurance company. So, let's take our handy dandy. Where'd my whiteboard go? My whiteboard was up there. It's disappeared. Damn Russians. You know, them Russians are into everything. There we go. Now take your handy dandy pen. Let's make sure it's red. And I want you to put a bracket around this one right here. That is your payment. Okay? Now the payment to the insurance company, remember, you're working for the insurance company because you're not sitting around at your home. Miss Riddle might, because she's got educational posters in her room. But she may do this, you know, from a client standpoint. But most of the time, if you're doing expected value, you're working for the insurance company. So the insurance company is who you're an actuary. That's what an actuary does. They crunch numbers. They sit in the office all day and do nothing but crunch numbers. All right? So 200 is plus because the insurance company is bringing that money in. The reason these are minuses is because what? They're paying it what?
Paying out.
Paying out. So you need to make that distinction because a lot of people don't understand that. This is from the insurance company's point of view. So this minus is a payout, which is a claim. And this is a payout, which is the value. And this is a payout. And then the others, these things right here, these are your probabilities of the event happening. This is a probability. And this is a probability. So if you really want to get technical, your formula that we learned on the previous slide is right here, and right here.
Okay, that's what I was trying to figure out. I was like, where does this thing start and end?
Yeah. And see, what they don't do is they don't tell you about the initial payment right here. See, that gets a lot of people screwed up. They don't understand where that came from. So this is your formula, and this is your formula, and this is your formula. How many times you use the formula? Depending on how much they give you. If they just give you 2 examples, then you just use the formula twice and you add it to the payment. If they give it to you if they give you 4 examples, then you take the payment and you add 4 formulas. So what does the $60 mean? The $60 means that the company is basically bringing in $60 with payouts. Okay? This suggests that if the company sells many policies, then the return per policy on average is $60. Okay? What does insurance companies do with that $200? This is where your high schools fail you. What do banks and insurance companies do with the money that you give them? All right, Mr. Riddle, I'm going to pick on you. Do you have any idea?
No.
Okay, let me ask you another question, Miss Riddle. You can take it. I'm not going to ask you your age, but how long have you been out of high school?
2 years.
Okay. Miss Porter, how long have you been out of high school?
2 years.
Do you know that? Do you know what that $200 is, what they do with it after?
After we get out of high school?
No, no.
Oh.
I'm saying y'all should know that because y'all high school graduates. You should know this. What do they do with that $200? Either it's a savings account, an IRA, or a payment to an insurance company. What do they do with it? Do they let it sit in a safety deposit box?
No, I'm sure they don't.
They invest it. Y'all didn't know that, did you?
No.
Keep them stupid. You can
What do
control
they
them.
invest in?
What?
What do they invest in?
They invested in stocks. That's why they're bonded. That's why they have to give you a guarantee that they're going to give you that money back when it comes to a point they got to give it back to you. Especially with a savings account or IRA. Do you know that all banks are, each account is insurance by FICA up to what? $250,000? You know, you see that on the bank, on the front door, FICA insured or whatever. I can't remember the initials, but they're insured. So if you, let's say that, is it Mr. Bergeron? I can't remember. I know it starts with a B.
It's Bargeron, but it don't matter.
Bergeron. He hits the lottery and he wins $250,000. He takes that $250,000 and puts it in an IRA or a savings account. All right? The bank, on paper, is going to cover that $250,000. But what are they going to do with that actual quantity of $250,000? They're going to invest.
The bracket's going to go up.
They're going to put it in the stock market. Now over here on paper, if Mr. B comes in and gets, he said, okay, I'm going to go to the strip club. I want that $250,000 in cash and $2 bills. Okay? They give him that. Okay? They don't want to give him that. Why? Because they've invested. They got to pull it out so they can cover that $250,000. They got to pull it out of the stock market. Okay? But on paper, they'll give him $250,000 and then they'll pull that money out because they don't have it anymore. Okay? And hopefully that $250,000 in a 24-hour period may have collected $4,000 or $5,000 depending on how they have. And that $4,000 or $5,000 is whose? The banks. Insurance companies, that's how they cover the insurance policy. Do you think they take that $200,000 and it magically covers a $50,000 claim that your house burns down? No. They take that money and they take Miss Riddle's $200, Mr. B's $200, Miss Porter's $200. That's $600. They invest that money. They put it in a mutual fund, and in 5 or 6 years, it turns into what? Turns into $5,000 or $6,000. You take that $200 and you multiply that by 5,000 people. You're talking major what? Money. And they invest it. Now, do they invest it in pork bellies and orange juice? No. They put it in mutual funds, which is your very, very, very conservative funds, which mutually grow over time. They don't lose money.
Like the longer your money sits in there,
The more money it makes.
Collect.
Mm-hmm.
That makes so much sense.
And I guarantee you, there are people in this room and in Oconee and East campus that did not know that.
I did not know that. And I'm taking business courses.
Yep. Well, you know the old saying, if you keep the people stupid, you can control them better. And I am a firm believer that our government wants to keep America stupid. I'm a firm believer of that. Not all the government, but some of the government. A gambler's fallacy, and this is a test question, and no, they're not a test question. This is a homework question, and this is also a standardized test question, so you might want to write this down. The gambler's fallacy is the mistaken belief that a streak of bad luck makes a person due for a streak of what?
Good luck.
Luck has nothing to do with it.
No.
It's just how what? It's how the die falls or how the cards fall. I'll give you, hold on, I'll let you type that. There you go. Now the question on a standardized test would be something like, somebody's been sitting, Mr. B is sitting at the blackjack table, and he's done lost $1,200. And what does he say to himself? Well, I'm due a streak of good luck sometime. That's what Vegas wants you to what?
Believe.
That's what they want you to believe. The only reason you win at blackjack is that's the way the cards what? Fall. You could sit down and win 5 or 6 hands, or you can sit down and lose 5 or 6 hands. It has nothing to do with your luck. It has nothing to do with how many rabbit's foot you got in your pocket. It has no idea of the way you wear your hat. Nothing. Nothing has anything to do with you winning except the way the cards fall and the way the die roll. Suppose you're playing the coin toss game in which you win $1 for heads and lose $1 for tails. After 100 tosses, you are $10 in the hole because you flip perhaps 45 heads and 55 tails. So you keep playing the game. You continue playing until you've tossed the coin 1,000 times, at which point you've got 480 heads and 520 tails. Does the result agree with the law of large numbers? Have you gained back any of your losses? Well, what is 480 divided by 1,000? 0.48. So you've got a probability of 0.48. What is the probability of heads?
50%.
Okay, down here it was 45. So what's happening? You're approaching that what? You're approaching the 0.5. So that means, does the result agree with the law of large numbers? Yes. It's getting closer and closer to that 0.5. From 0.45 to what? 0.48. Have you gained back any of your losses? Yeah, you've gained back a little, but you're not in the red because what? 520 is over 50. Okay? And that's what they're telling you. Okay? Your losses has actually increased. Again, am I going to ask you this on the test? No. This is not a standardized test question. What is a standardized test question? The standardized test question is that question right there. All right? I doubt very seriously, you're not going to get a test question from me like this. Now, you might get one in homework, but all you got to do, you really don't have to do any calculating, do you? You just got to think. Okay, this is just a gambler's fallacy. If you're tossing a coin 6 times, the outcome, blah, 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 are equally likely. A farmer knows at this time of year in his part of the country the probability of rain on a given day is 0.5. People ask me to this day, because I grew up row cropping. My father was a row cropper. We ran 2 or 3 combines. We would combine wheat and barley, and I'd have to crawl up in them combines and unclog the combine, and it'd be hot. That ain't why I don't row crop. Why do I not row crop? Because I would rather take my money and go to Vegas. Why? Because you are dealing with weather, and can you control the weather? No. People ask me this day, why don't you plant those bottoms in corn and combine them? I'll take that money and I'll put it in cows, or I'll put it in pigs, or I'll take it to Vegas. At least I can control when I lose and stop in Vegas. At least I know, okay, I'm losing, I need to get out of here. Okay, I have that control. When you plant that seed in the ground, do you have any control over it?
No.
Hail to the no. And that's why I don't row crop. Because my dad, and he was a good farmer, but he could not control the weather. Now, can you control the weather by having irrigation? Yes, you can. But what is the problem with irrigation? It takes a buttload of money to cover the cost of it. So, the reason I bring that up is because there's different types of farming, but if you don't have irrigation and greenhouses, I wouldn't suggest it. Unless you have a very well-known pattern of weather. And in South Carolina, how predictable is our weather?
Not really.
Yesterday it'd be 106, today it'd be 32. Okay? And I'm exaggerating. I think it was, close to 70.
Today.
Yeah, it's going to be 70 degrees today, 65 degrees. Tomorrow we could have an ice storm. Okay? So, unless you have, and that's when you're talking about probability, that's the number one key. If there's a pattern. If Mr. B goes to Vegas and he sees that these two die are rolling sevens every single time somebody throws them, first of all, what is he going to say to himself? Something's not right. But if he's smart, is he going to take advantage of it?
Yes.
Yes. Same thing with farming. Row cropping is truck farming is when you grow butter beans and tomatoes and you take them to the farmer's market. We used to do that too. I used to make all kinds of money. I would pick blackberries and shell butter beans, and I'd sell at $5 a quart. Buddy, me and my sister made hundreds of dollars during the summer when we would do that. Anyway, make a long story short, truck farming as well as row cropping, corn, wheat, barley. If you've got a patterned, 90%, 80% pattern, weather pattern, then yes, go for it. But in South Carolina, hell to the no. You don't know. We have a drought in the middle of dadgum February. Okay? A farmer knows at this time of year in his part of the country, there's that pattern. The probability of rain on a given day is 50%. It hasn't rained in 10 days, and he needs to decide whether to start irrigating. Is he justified in postponing irrigation because the region is due for a rainy day? Hail to the no. What happens if those soybeans or that barley or that corn doesn't get rain for a couple of days? They're going to die. So you're going to have to irrigate. You can't rely on the weather pattern. And there we go. And you cannot say due for rain. So he needs to irrigate. And the whole point of irrigation is not to keep it's basically the point of irrigation is to keep your crop from what? Dying. It's not to give your fields enough water to grow on. That's not what irrigation is for. Irrigation is there for emergencies. Is to keep the ground at a certain moisture level so that the plants will not die. That's what a lot of people don't understand. Okay, I'll shut up. And see, this is another gambling house. I'm not going to go over these because these are just scenarios which you're thinking. Basically, you're not due what? You're not due good luck. Are you owed anything? No. And nothing is free. I hate to be the bearer of bad news, but nothing is free. Even though we have some people that think you can rob Peter and pay Paul and it's free. I don't know where they get that from. And the last section, what time is it? I'll go ahead and introduce it. Counting. Should be counting. And counting is basically something that y'all know how to do, but it's not the counting that you're thinking of. Okay? The counting that we're thinking of is with factorial. Okay?
Were these the factor tree things?
No, we don't do those. I don't do those. I don't teach them because that's confusing to a lot of students. This is where we're dealing with exponents and factorial. Exponents and factorial. And this is an exponent. Y'all know that, and all of you should know this. Anytime you multiply a number times itself, it can be written as an exponent. If you don't know that, then we are in trouble. All right? Now, how many 7-number license plates are possible? 7 number. Well, how many in a number? 0 to 9 is 10. Everybody with me?
Yep.
Yeah.
Okay, and there's 7 spaces. Okay, I want you to rewrite this. How many 7-space license plates are possible? 7 spaces. In other words, there's 7 spaces for you to put a number. And those numbers are from 0 to 9. So that's 10. So that'd be 7 to the 10th power. Okay?
Big number.
Say again?
It's a really big number.
It's a BA number, yes. Or 10 to the 7th power. Now, I want you to highlight that 10 right here. And the base is the numbers. How many numbers? And then the exponent is how many what? Spaces. So you need to highlight the exponent as spaces. That's why I told you to change this to spaces. Change that to spaces. If you change that to spaces, the questions will be a whole lot easier, especially with a license plate. Now, why is this just exponents? Well, it's exponents because they just said 10 numbers in each space. And if you get 10 numbers in each space, whether it's an alarm key code or it's a license plate, you're going to put the numbers on the base. So for an alarm, if y'all have an alarm at home and there's 4 spaces, then it'd be 10 to the what? 4th. Be 10 to the 4th power. So that's a basic standardized test question right there, which is still a big BA number. 10 million different possible license plates. So, Mr. B, if you get thrown into the jail, that's what you don't know. They don't make license plates anymore. They don't make people work anymore in jail. They let them lift weights all day and watch cable TV. Don't want to hurt the prisoners. Maybe that's why I'm not in politics and I'm not a police officer. Permutations. Permutations have to deal with order. So you got permutations at the top. I want you to put in parentheses order. Order, order, order. Y'all ever had chia seeds?
Yeah.
I put them in my drink now with my vodka. The vodka doesn't eat them up.
Usually they like expand and turn on.
Yeah, they do.
Like, it's really weird.
Yes, and they're good for you too.
They are, and they're not terrible. Have you ever had chai pudding?
Yeah, it's good. All right, permutations have to deal with order. And they can be no more than once. And the order matters. Number one thing about permutations is order. Miss Porter, what time is it?
9:58.
And in factorial is what we're going to be using. Now, I'm going to stop right there, and we're going to cover factorial. Miss Porter, write that down. Start with factorial. We're going to start with factorial when y'all come back, okay? I want to get the roll right quick because I want to make sure that every once in a while I want to actually take the roll. I don't mind, do you? I gotta be a decent teacher every now and then, right? Y'all just not want to talk to me or what? Miss Riddle, I thought you said you were gonna talk.
It's a Monday.
It's a Monday. Y'all know what? There's this thing in life. It's called life. Okay? So y'all need to get with the program.
You know something that sucks?
What sucks?
everybody in my household is off of school or off of work today except for me.
Well, I will tell you why that is so. You're dealing with a school that not only covers one county, but covers what? 3 counties. All the school districts are off on different days and all that. They're not always on the same day. So Tri-County Tech basically throws the district out. They don't even go with the district because they don't line up. So what Tri-County does, the calendar committee, puts all their emphasis on breaks. So they try to move all the days off to the spring and fall break. So that way y'all have more time off. Instead of 2 days, they take a couple like Columbus Day and whatever day, and they forego that and put it at the spring break or fall break. That way you get 3 or 4 days or whatever instead of 2 days or whatever the case may be. And the reason they do that is they cannot try to please 3 counties, because if they try to please 3 counties, that we never would be. We would be in constant turmoil all the time. So that's why. And I'm sorry, but that's fact of life. And I'm just doing this right quick. Okay, Mr. B is here. Your name is officially Mr. B now.
All right, that's fine.
I like my French, but I can't fathom that ever. I can't remember names, much less French descent names. Okay, Miss Anya Sador is not here. She's drunk. Mr. Bowen, because he hadn't shown up and I don't know when. Okay, how many people are up there? Carr's there, Foster, Morgan, and Riddle, right?
Yes.
All right, y'all get out of here. See y'all Wednesday.
All right.
Go enjoy President's Day, Miss Riddle. See y'all.
See you. Have a good day.